Chapter 4, Section 3, Introduction to Polynomials. The first part of this chapter requires a lot of vocabulary. So our first word is monomial. And a monomial is a product of numbers and variables raised to whole number exponents. Now, it's important to note that no variables are in the denominator. No variables are under roots. And there are no negative exponents. Okay, the next word is a binomial. And a binomial is a sum or difference of two monomials. Okay, so it's two things being added or subtracted, and the two things are monomials. Then you have a trinomial, which is the sum or difference of three monomials. Okay, so bi means two, bicycle, 2 wheels. Tri means 3, tricycle, 3 wheels. Okay, so help you to remember. A polynomial is the sum or difference of one or more monomials. Okay, so a monomial, a binomial, a trinomial, those are all polynomials, and then anything 4, 5, 6, 7, 8, 9, 1,000 terms would all just be called polynomials. The standard form of a polynomial is from the highest power to the lowest power. And that's using the exponents. Now, the degree of a polynomial is the highest power on the variable. And that's if it's a single variable, or it's the sum, and it would be the highest sum if variables are multiplied together. So you would take the exponent. If you have just x's, let's say x squared, x to the 5th, x to the 10th, well then the degree would be 10 because 10 was the biggest. But if I have variables multiplied together, like x squared, y squared, then the degree would be 4 because I'd have 2 plus 2. Okay, coefficients are the numbers before the variables. And that's attached. And they're being multiplied. Okay, the leading coefficient is the coefficient on the highest power monomial in the polynomial. And then a constant, oh sorry, I didn't even read that. A constant is a number with no variable. So here's an example. We're going to say, which of the following expressions are polynomials? If the expression is a polynomial, we're going to write it in standard form. We're going to give the name of the polynomial. So is it a monomial, trinomial, binomial? We're going to give it the degree. We'll say what the coefficient is, all the coefficients. We'll say the leading coefficient, and we'll label the constant. So we'll start here with x plus 3. X plus 3 has like a little invisible 1 on there as its exponent. So it does have a positive whole number exponent. The x is not under a root. It's not in the denominator. So this is a polynomial. So we'll just say yes, it's a polynomial. The standard form is the highest degree first. Well, since there's no x here, it would be like x to the 0. So highest degree would be 1. So this is already in standard form. Okay. The name of the polynomial, we have two terms. So that is a binomial. The degree is 1 because that's the highest variable on an exponent on a variable. The coefficient is 1 because there's nothing being multiplied by that x, so there's like a little invisible 1 in front of there. The leading coefficient is 1, and the constant is 3 because that is the number with no exponent. Or sorry, with no variable. Okay, here's our second one. We have positive whole number exponents, so yes, this is a polynomial. The standard form, we need to put that highest exponent first. So the standard form is to go 2, 1, none. So we count down. Our name, we have 3 terms, so this is a trinomial. The degree is the highest exponent, so that's 2. Our coefficients are -1 and 2, because we have a -1 on the x squared and a 2 on the x. Our leading coefficient is -1, that's out front, and our constant is -5. Okay. 5 is a polynomial. It can be a number by itself. We've got that little 0 on that x there, which made the x go away. So the standard form of it is just a 5. Oh, it's a monomial because it's by itself. That's the name, monomial. Wrote that on the wrong line. The degree is 0 because the variable would have a 0 exponent. The coefficient, there's no coefficient. That way, there's also no leading coefficient, and the constant is 5. Okay, now, we need to look at this one, and let's look at all of our exponents. All of these that don't have an exponent are 1s. So together, the degree of that would be a 2. The degree of this would be a 3. This would be a 3. And that would be a 0, 2, and 2. When we have competing degrees, they're the same, we're going to go alphabetical. And that means we are going to put the highest exponent on the 2. Okay, we're going to put the positive number out front. So we're going to put the xy squared first, then the x squared y, then we have our 2's, and then we have our constant. The name on this is just going to be polynomial. It doesn't have a special name. The degree is 3. The coefficients are -5, -1, 1, 1, and -1. We don't have to list these twice, so we can take those out. The leading coefficient is 1, and the constant is -5. Here I have -3x plus 1 over x. Because I have an x in the denominator, this is not a polynomial. So I can't name it or do anything with it. Here I have -3x plus x to the -1, which is actually the same thing, but I have a negative exponent. So we are not a polynomial. Okay, section 4, adding and subtracting polynomials. To add and subtract polynomials, we have to know what like terms are, and like terms are terms with identical variable portions. Okay, and what this means is that the variables have the same exponents. Okay, they match. So examples of some like terms. X squared and negative 10x squared are alike because they both have x squared on them. 2x and 7x. 3xy and negative 2xy. These are like terms. Things that are not alike. X squared and x to the third. They're both x's, but one has a squared and one has a third. X and y are not alike. 3xy and x squared are not alike. So the variable, the letter has to match, and the exponent has to match. So when we have that, we can combine them. It's called collecting like terms, or adding and subtracting on polynomials. So what we do is we identify the things that match. Okay, I have x squared, those match. Plain old x, and then I have no x and no x. Sometimes it's helpful to rearrange these and write them together. So I could take my 5x squared, and then I have a negative x squared or minus x squared. So I got those. Then I have x, and it's positive, so I'm going to put plus. Negative 2x. Now remember, the minuses have to stay in front of what they were already in front of. And then I have minus 3 and minus 5. Rearranging them groups them together so I know which things to combine. 5 minus 1 is 4x squared. Now the exponents never change when you're adding and subtracting these things together. 1 minus 2 is negative 1. And negative 3 minus 5 is negative 8. So that has been simplified by combining like terms. Now here I have denominators. So I need a common denominator between a 3, a 5, and a 6. Well, 5 and 6 both go into 30, and conveniently, so does 3. So I'm going to make my denominator 30 so that I can add everything together. No, I don't need to do that. I'm so sorry. First I'm going to rearrange it. I have x's and x's, and then I have x squareds, okay, and I only need my like terms to have common denominators. So my common denominator between these two is going to be 5. Well, that's a 1, so multiply it by 5. So I'm going to have 5x over 5 minus x over 5. Here my common denominator is going to be 6, so I need to multiply this by 2. I don't have to change that at all. And that will give me 5 minus 1, which is 4, and negative 2 plus 4, which is 2. But this can be reduced, 2 and 6. And we get x squared over 3. Okay, we're going to do something similar again. I've got x squared, so I'm going to put my x squareds together. And then my x's together. And then my no variables together. I'm going to work on my like terms between a 5 and a 2. That's a 10, so I'm going to multiply both of these by 5. Between a 3 and a 5, that's a 15. So multiply those by 5 and these by 3. And then again here, I do the same thing. So I'll have negative 12x squared over 10 plus 5x squared over 10 plus 5x over 15 plus 12x over 15 minus 6 over 15 minus 1 over 15. Negative 12 plus 5 is negative 7. 5 plus 12 is 17. And negative 6 minus 1 is negative 7. Okay. Same idea again, except these are all already 5s. So I just need to make this one a 5. So if I multiply that by 5, it's going to be 15x over 5. Now you do not have to rewrite them next to each other. I can just take the x squareds. I have negative 3 plus 1. So that's negative 2. And that took care of those two. I have 15 plus 3, so that's 18. That took care of those two. And then I have negative 2 and negative 2. That is negative 4. And that took care of those two. Now when I add or subtract polynomials, I'm going to do the exact same thing. I'm going to collect like terms. When I have an addition sign in between my two polynomials with my parentheses, the parentheses basically just go away. So here I have an x to the third and an x squared. Those don't match, and there's nothing else that matches them, so I just rewrite those. I have a 4x and a 3x, so I put those together. And I have a negative 6 and a positive 5, so I put those together. I'm going to do the same thing. Here I have a 5 and a 4. I have no other 5s or 4s, so I'm going to go ahead and write those down. And then I have a 3. I don't have any other 3s, so I'm going to write that down too. Then I have a 2 and a 3x squared. And then I have a 3 and a negative 2x. And then I have a negative 1 and a positive 10. And so I've added those polynomials together. So again, when you have an addition sign, you can just ignore the parentheses. It's when you have a minus that you need to worry. So when you see this negative sign right there, that means that I need to take everything in here and change the sign. So I'm going to have negative 4x to the third minus 3x squared minus x minus 1. All that stays the same. But here, this negative makes that positive. This negative makes this negative. Negative makes a positive. Negative makes a negative. Once I've done that, now I can collect my like terms. I have cubes. Negative 4 and positive 2 give me a negative 2. I have squares. Negative 3 and negative 3 give me a negative 6. I have x's. Negative 1 and positive 4 give me a positive 3. And then negative 1 and negative 6 give me a negative 7. When I have minus and a 3, I need to distribute in this negative. So I'm going to multiply both of those by negative 3. This first one is not changing, so I'll rewrite that. Negative 3 times 4 is negative 12. Negative 3 times negative 6 is positive 18. 2x and negative 12x go together. Negative 1 and positive 18 go together. Okay. Again, I have this negative. Nothing's happening to the first parentheses. And do be careful because maybe there could be a negative sitting out here. You want to keep an eye on that. Okay, this negative out here is going to change all those signs, not just the first one. That is the biggest mistake I see people make, is they'll do this one as a minus 3, but then they leave all those the same. Don't do that. Change every single sign. Negative 4 and negative 3 is negative 7. I only have 1 squared, so I just rewrite it. I have positive 1 and negative 4, that gives me negative 3. And then negative 1 and positive 6 give me 5. And last one of these, I'm going to multiply in. This is a positive 2. Again, nothing's happening out here in this front parenthesis. Then this, everything's getting multiplied by 2. So I get 6x squared, 2x, and 12. have this 1 cube, negative 3 plus 6 on the x squareds, 1 minus 2. And that is how you add and subtract polynomials. Your questions for this assignment are: define monomial, define binomial, define trinomial. When you add and subtract like terms, what has to match? And when there's a negative outside of parentheses, what happens?